This video is a review of exponential functions, composites, and inverses. This is AP Pre-Calculus topic 2.1 through 2.8. If you appreciate this content, please give it a like. For 1 through 3, use the information below to write an equation for the following arithmetic sequences. Then find the 11th term of the sequence. Number 1, a at 4 equals 7, and a at 9 equals -3. Here's the formula for the nth term of an arithmetic sequence. I'm going to put in a9 for an and a4 for ak. But a9 is -3, so we have -3 is equal to 7. We're looking for the common difference. 9 minus 4 is 5, so I'm going to put that in front, and so now we have 5d. Subtracting 7 from both sides, we get -10 is equal to 5d. Dividing both sides by 5, we get d is equal to -2. Putting this back in for d, we can go ahead and write a rule for the nth term of the arithmetic sequence. an will equal a4, I'm going to go ahead and put 7, but just remember that k is 4, plus d, well, the common difference is -2, so I'm going to put -2, and then it's n minus k, n minus 4. So this is the rule. Now we can use this rule to find a11. a11 will be 7 minus 2 times 11 minus 4. (11 minus 4 is 7, so a11 will be 7 minus 2 times 7. So a11 will be 7 minus 14. So a11 is -7. For number 2, they gave us that the common difference is 3. So I can go straight to the rule, which is an equals. For ak, I'm going to use a2, and then the d is 3. So then n minus k becomes n minus 2. So an is equal to a2, which is 5, plus 3 times n minus 2. So there's the rule. Now I'm finding a11, which will be 5 plus 3 times 11 minus 2. That's 9. So a11 is going to be 5 plus 3 times 9 is 27. So a11 will equal 32. For number 3, they give us a graph. Graphically, the common difference d is the slope of this graph. So, rise over run. This is down 1, right 2. So that's -1/2. So we know d. So we should be able to pick any point off of this and plug it in for ak. So I'm going to begin to write the rule. an is equal to. I'm just going to use a1 as ak. So maybe I'll just go ahead and write a1 for a second. So a1, and then d is -1/2, so I will just put -1/2, and then it's n minus k. That's n minus 1 if I use this point right here. But of course a1 is 7. So to save time, I think I will just erase the a1. I just put a1 here so you can see where the 1 is coming from. But it is really a 7. So this is the rule right here. That leaves me to find a11. I think I'll put it over here. So a11 will be 7 minus 1/2 11 minus 1. So A11 will be 7 minus 11 minus 1 is 10. Half of 10 is 5. So A11 is 2. For number 4 through 6, use the information below to write an equation for the following geometric sequences. Then find the 8th term of the sequence. Here is the general model for the nth term of a geometric sequence where, well, Gn is the term n, Gk is term k, and r is the common ratio between the successive terms. I'm going to plug in G6 for Gn and G3 for Gk. I always like to put the larger index in the front. So I will have G6 is equal to G3 times r. That's what we need to find. And then n minus k, so that's 6 minus 3. So G6 is 1.5. So I have 1.5 is equal to 12 times r to the third power. So dividing both sides by 12, actually first let's rewrite this as a fraction. 1.5 is 3 over 2. It will be easier to see what I'm doing if I write this as a fraction. So when I divide both sides by 12, this 12 is going to end up multiplying the denominator. So on my next step, I'm going to have 3 over 24 is equal to r to the third power. But this reduces down to 1 over 8. And if you take the cube root of both sides, you get r is equal to 1/2. Now I can write the rule using this 1/2. So I get Gn is equal to G3, I'm going to erase this in a second, times r, so that's 1/2, to the n minus k power. So this will be to the n minus 3 power. But let's erase G3 and put the 12. So this is the rule, the equation that we were asked to find. Now we need to find the 8th term of the sequence. So that will be G8. Okay, so that's going to be 12 times 1/2 to the 8 minus 3 power. So that'll be to the 5th power. 2 to the 5th power is 32. So G8 is going to be 12 times 1 over 32. In other words, 12 over 32. So let's see, that would reduce down to 6 over 16. That reduces down to 3 over 8. Let's do the same thing for number 5. So we have G6 is going to equal G1 times r to the 6 minus 1 power. So that's r to the 5th power. But that is 96 is equal to negative 3 r to the 5th power. Dividing both sides by negative 3, we get negative 32 equals r to the 5th power. Taking the 5th root of both sides, we get r is equal to negative 2. Actually, don't put a box around that. So now we can write the rule. So Gn is going to equal G1, I'm going to erase this in a second, times r, which is negative 2, to the n minus 1 power. But let's erase the g1 and put the negative 3. This is the equation that we needed. Now we can find the 8th term, g8. g8 will equal negative 3 times negative 2 to the 8 minus 1 power. So that'll be to the 7th power. I'm going to use my calculator. 2 to the 7th power. That's negative 128 times negative 3 is positive 384. Number 6, they gave us a graph. We can perceive the common ratio by dividing the value of each term by the previous term. So 3 divided by 6 is 1/2. So that's the common ratio. Okay, we could also do 1.5 divided by 3, I guess. So 1.5 divided by 3. Yep, this is also 1/2. Notice that g1 is equal to 6. I'm going to use this as gk in my little formula there. So I'm going to write for my rule gn is equal to g1, I'll just put it temporarily, g1 times the common ratio of 1/2 to the n minus 1 power. N minus 1 power. But this is gn is equal to 6 times 1/2 to the n minus 1 power. So this is the equation that we wanted. Now we need to find the 8th term, which is g8. So that will be 6 times 1/2 to the 8 minus 1 power. That is to the 7th power. On the previous problem, we learned that 2 to the 7th power is 128. So this will be 6 over 128. And then it's just a matter of reducing this down. g8 is 3 over 64. Number 7. Scientists are studying the growth of a particular bacteria colony in a laboratory. The population of the bacteria colony can be modeled using a geometric sequence where the first day of the study is day 1. The population on day 5 was 7,000 bacteria, and the population on day 8 was 32,000 bacteria. What was the population of the bacteria colony on day 7 based on the model? Looking at the general model for a geometric sequence, we can see that g8 will equal g5 times the common ratio to the 8 minus 5 power. The population on day 8 was 32,000, so g8 is 32,000. The population on day 5 was 7,000, and that's times r to the 3rd power. Dividing both sides by 1,000 is going to turn this, I'm just making the numbers smaller because I can. So this will be 32 is equal to 7 r to the 3rd power. Dividing both sides by 7, we get 32 over 7 is equal to r to the 3rd power. I could take the cube root of both sides. That is the same thing as raising both sides to the 1/3 power. I'm choosing to do it that way. So raising both sides to the 1/3 power will cancel out this 3 on the r, leaving me with just r. So r is equal to 32 over 7 to the 1/3 power. So now I'm going to write the equation. So gn will equal g5. I'm going to erase this in a second, but gn will equal g5 times r, which is all of this business, to the n minus 5 power. Okay, when you raise a power to a power, you multiply, so I can just stick it on the end there. Now, G5 was 7,000. So this is an equation for the population of bacteria on day n. Let's use this equation to find the population on day 7. So I'm just putting in 7 right here. So G7 will equal 7,000 times 32 over 7. 7 minus 5 is 2. And 1/3 times 2, that's just 2/3. So I'm just going to put this in my calculator. So that's the answer, except I just realized I put a 1 right here. This should be a 7, G7. During the busy season, the most popular roller coaster at a large amusement park experienced a technical issue and was forced to shut down temporarily. The number of people waiting in line for the ride to reopen can be modeled by an arithmetic sequence. After 7 minutes, there were 46 people in line. After 15 minutes, there were 134 people in line. According to the model, how many people will be in line after 19 minutes? Using the general model for an arithmetic sequence, I can write A15 is equal to A7 plus the common difference times 15 minus 7. A15, after 15 minutes there were 134 people. So 134 is equal to A7 is 46 plus 15 minus 7 is 8. So I'm going to go ahead and put 8D. Subtracting 46 from both sides gives me 88 is equal to 8D. Dividing both sides by 8 gives me D is equal to 11. Now I can write the rule for the nth term. So AN is going to equal A7, I'm going to erase this in a second, plus the common difference of 11 times n minus 7. However, the A7 is 46. So there's my equation. I need to find how many people will be in line after 19 minutes. So I'm going to go ahead and find A19, which will be 46 plus 11 times 19 minus 7. Okay, so A19 will equal 46 plus 11 times 12. That's 46 plus 132, or 178 people. The graph of the function f is shown above. Which of the following could be an expression for f? The a value in the front tells you whether the curve will be above or below the x-axis. If the a value is positive, it's above the x-axis. So because I see that the exponential curve is above the x-axis, I know that a must be positive. So the answer is not B and the answer is not D. The b value, the 3 versus the 1/3, now will tell us if the graph is getting closer to 0 or further away from 0, from left to right. If the b value is between 0 and 1, then from left to right, the curve should be getting closer and closer to 0. And that's what we see here. So the curve is getting closer to 0, so the b value should be between 0 and 1, like 1/3. So the answer is C. All right, the graph of A would be exponential growth like this. Number 10, the exponential function is defined by f of x equals a times b to the x power, where a and b are constants. If f at 2 is equal to 36, and f at x plus 1 over f at x is 3, for all values of x, which of the following is the expression for f of x? So, f at x plus 1 divided by f of x. This is just a weird way of saying the next term in the sequence divided by the previous term in the sequence. And we know that the common ratio, which we call r, is what you get when you divide each term by the previous term. Okay, so if f at x plus 1 is a term, then the previous term is f of x. So this is just a weird way of telling us that r is the common ratio. I called it r for common ratio, but based on the way they have it defined, in this context it is going to be called b. So b is 3. They tell us that f at 2 is equal to 36, meaning if we plug in 2 for x, we should get 36 for the answer. So that gives us a times 3 to the x power, so to the second power, should equal 36. That means a times 9, so this is 9a is equal to 36. Dividing both sides by 9, we get a is equal to 4. So that's it. A is 4 and b is 3. That means the answer is B. Number 11, the exponential function g is defined by g of x equals a times b to the x, where a and b are positive constants. The table gives value of g of x at selected values of x. Which of the following statements is true? The a value is always the value at 0. We are given 0 right here, so that tells us that a is 72. We can find the b value by taking one term divided by the previous term. I'm going to use these two because they are simple numbers to use. So I can find the value of b by dividing 8 by 24. 8 over 24 reduces down to 1/3. So the answer is A. G demonstrates exponential decay because a is positive and b is between 0 and 1. Number 12, which of the following exponential functions demonstrates exponential growth? Exponential growth looks like this. Exponential decay looks like this. To be either one of these, the a value has to be greater than 1 because the graph has to be above the x-axis for exponential growth or decay. So if we are talking about exponential growth, the a value, all right, the number in front, definitely has to be positive. So we can forget about b and d. We will know the difference between growth and decay based on the b value. It's going to be exponential growth if the b value is bigger than 1, and exponential decay if the b value is between 0 and 1. So for growth, we want the b value to be bigger than 1. 3 over 2 is bigger than 1. So the answer is C. Number 13, the end behavior of an exponential function h is described by the limit statements above. Which of the following could be h of x? The limit as x approaches negative infinity of h of x equals negative infinity. So as we move towards the left, the value of the function falls. So I know that as we move towards the left, the function must be falling. So the left end behavior has to be like this. Because I know it's an exponential function, I know the x-axis is an asymptote. So I automatically drew it in such a way that it satisfies the other end behavior. the limit as x approaches positive infinity of h of x is 0. This means as we head towards the right, the curve is approaching 0. So this little picture I've drawn does satisfy both. Now, which one of these answer choices matches what you see here? It has been drawn below the x-axis in order to match these limit statements. That means that the a value has to be negative. So that's narrowing it down to either b or d. So we can forget about a and c. Okay, the a value has to be negative. So how do we know whether it's going to be b or d? Look at the b value. If the b value is between 0 and 1, like the 2/3, then from left to right, the function will be getting closer to 0. And that's what's happening here. Notice how the function is getting closer and closer to 0. That's what happens when the b value is between 0 and 1. So the answer is D. Also, option B would look like this. Below the x-axis, because the a value is negative, because the b value is greater than 1, from left to right it has to be getting further away from the asymptote. So this is what the graph would look like for b. Number 14, the exponential function k is defined by k of x equals 5 times 2 over 7 to the x power. Which of the following statements about k is correct? Let's draw a little sketch. Because the a value is positive, I will definitely draw the curve above the x-axis. Because the b value is between 0 and 1, the curve should be getting closer and closer to 0 as we move from left to right. So this graph is decreasing and concave up, right? It's the left side of kind of a bowl shape, so you know it's going to be concave up. So the answer is C. Number 15. Selected values of the function f are shown in the table to the right. Which of the following claim and explanation statements best fits these data? The answer choices are about whether the curve of best fit will be a linear function or an exponential function, and why. A linear model is most appropriate when the output values have a common difference over equal length input value intervals. An exponential model is most appropriate when the output values are proportional over equal length input value intervals. Two of the answer choices talk about the output values being proportional, but two of them talk about the input values being proportional. The input values being proportional, that never tells us anything. So those will not be the answers. So inputs proportional, nope. Inputs proportional, no. So it's either going to be A or C. So let's see, let's take a closer look at A. F is best modeled by a linear function because the output values are proportional? No, for if the linear model is going to be most appropriate, we're looking for a common difference, not output values proportional. So A is not going to be the answer. So by the process of elimination, the answer would have to be C, even before we look at the data. But let's follow through. So C says that f is best modeled by an exponential function because the output values over consecutive equal length input value intervals are proportional. Okay, so that matches this statement. Now, to follow through, let's just look at the data and see if the output values are indeed proportional. That means if we take each output value and divide by the previous output value, we should get the same answer. So I'm going to use these two just because the numbers are easiest. So for example, 8 divided by 2 is 4. Okay, so the common ratio, well, the ratio for this pair is 4. And then 32 divided by 8 is also 4. Okay, so it would be the same thing if we checked the other pairs. Alright, so it does make sense. So the answer is C. 16. Which of the following functions is an equivalent form of the function y equals 4 to the 3x power? Looking at the answer choices, they all have just a single x as an exponent, nothing multiplied. We have learned that c to the ab power is equivalent to c to the a power all raised to the b power, because when you raise a power to another power, you multiply. So we can use this principle to rewrite this equation as 4 to the third power all raised to the x power. That's how we kind of get the x by itself. Now, 4 to the third power is 64. So this would be the same thing as y equals 64 to the x power. So that's how we know the answer is C. Number 17. Which of the following functions is an equivalent form of the function y equals 9 times 4 to the x power? Okay, so on these ones, x is not kind of all by itself. In fact, what these all have in common is they all have a 2 in this position right here. So I think I'm going to start with that and see what happens. If I want to rewrite this so that I have a 2, I could rewrite 4 as 2 squared. Okay, and then the x is still there, so 4 to the x can be rewritten as 2 squared, 2 to the 2x. So then I'm just going to bring down the y equals 9 times the rest of this. So based on that, I can already see that the answer is C. Number 18. Which of the following functions is an equivalent form of the function y equals 3 to the x plus 3 power? All of these different forms have just a plain x, not a sum. So we will use this property of exponents that we have learned. C to the a plus b power can be rewritten as c to the a power times c to the b power. Similarly, y equals 3 to the x plus 3 power can be rewritten as y equals 3 to the x power times 3 to the third power. 3 to the third power is 27, and I'm going to put that in the front. So this would be the same thing as y equals 27 times 3 to the x power. Oh, look, it's right here. And the answer is D. Number 19. Which of the following functions is an equivalent form of the function f of x equals 4 to the x minus 2 power? Well, this is almost the same as, remember when I said c to the a plus b power? Well, we can easily write c to the a minus b power. And that's going to be the same thing as c to the a times c to the negative b. So that's what I am about to do right now. So we could write f of x is equal to 4 to the x power times 4 to the negative 2 power. And that would be the same thing. When you have a negative exponent, the negative exponent drops the expression down to the denominator. So we have f of x equals 4 to the negative 2 power is the same thing as 1 over 4 squared. I'm putting it in the front. I still have the 4 to the x power. Of course, 1 over 4 squared is 1 over 16. So f of x equals 1 over 16 times 4 to the x power. And there it is again. How convenient. The answer is D. Number 20. The function g is given by g of x equals 16 times 9 to the x power. Which of the following is an equivalent form of g of x? So let's see. All of these have a 3 in this position right here. So I could get a 3 to show up in that position if I rewrite the 9 as 3 squared. So let me try that and see if I get one of the answers. So I could have g of x equals, for now I'm going to leave the 16 alone. The 9 could be written as 3 to the second power. I also already have this x in the exponent, so this would be 3 to the 2x power. Does that match anything? 16 times 3 to the 2x power. Well, that's d again. Kabam. 21. The function h is given by, they mean k. The function k is given by k of x equals 9 times 4 to the x power. Which of the following is an equivalent form for k of x? Okay, what do they all have in common? Okay, they don't all have anything in common. I see a 2 here and here. I know that I can rewrite 4 as 2 squared. So I'm going to kind of start with that and see how far it goes. So if I rewrite the 4 as 2 squared, then that would give me k of x is equal to, and I would still have the 9, and rewriting 4 as 2 squared, and then applying the x, I would have this. So does that give me any of the answers? I see the 2x there, but that's a 3. I see the 2x over here, but this is a 16. So that did not work. Okay, so that means instead of going for the 2, I need to go for the 16. So the way I'm going to go for the 16 is you need to understand that the square root of 16 is equal to 4. Well, I don't see any square roots, so what does that have to do with anything? You need to understand that the square root of 16 is the same thing as 16 to the 1/2 power. So 16 to the 1/2 power is equal to 4. So I'm going to use this fact right here. So let me go back and start again. So I can bring down this 9, and then 4 can be rewritten as 16 to the 1/2 power. The square root of 16 is 4. There's already an x there, so if I keep the x in the exponent, now I have this. So the answer is C. 9 times 16 to the x over 2 power is the same thing as 9 times 16 to the 1/2 x power. Number 22. Let f be an exponential function of the form f of x equals b to the x, where b is a constant. If the function g is the result of a horizontal dilation to the graph of f, then which of the following equations could represent the transformation from f to g? Quick side lesson. Compared to the parent function b to the x, what kinds of transformations are happening with the 2? A plus 2 on the end is a vertical translation by 2. Multiplying by 2 in the front is a vertical dilation by a factor of 2. Adding 2 in the exponent is like adding 2 inside of the parentheses. This is going to be a horizontal translation. In this case, a horizontal translation by -2. It's always the opposite of the way it looks for horizontal transformations. And what about this last one? Multiplying by a number all up in the exponent like this is like multiplying inside the parentheses. This is a horizontal dilation. In this case, by a factor of 1/2. It's the opposite of what it looks like, think reciprocal, but this is a horizontal dilation. Now, we are looking for a horizontal dilation to be happening. So, this is exactly what we need. We want g of x to be b to the 2x power. This would be a horizontal dilation. However, all of the answers are written in terms of f. So remember, f of x is b to the x power. So I need to rewrite this a little bit to make b to the x power show up so that I can make f show up. So I will rewrite this as g of x equals. We can rewrite this as a power raised to the power. So this would be the same thing as b to the x power squared. When you raise a power to a power, you multiply. So this would be the same as this. I rewrote it this way because we know that b to the x power is f of x. So I can now substitute f of x for b to the x. So this will become g of x equals f of x squared. So that's why the answer is D. 23. The exponential function g is defined by g of x equals -2 times e to the x. Which of the following pairs of statements correctly describes the end behavior of g? Let's draw a sketch. The a value is negative, the number in the front. That tells me that the curve is going to be below the x-axis. The b value is e, and don't forget that e is a constant, approximately 2.72. What matters is that this b value is bigger than 1. So b is bigger than 1, and this a value is less than 0. So when the b value is bigger than 1, the curve will get further away from the x-axis, from left to right. So it's going to be below the x-axis because the a value is negative. And it's going to get further away from the x-axis because the b value is greater than 1. So this is my picture. Now we are ready to discuss the end behavior. Let's start with the left end behavior. The limit as x approaches -infinity is 0. On the left, the curve is approaching the x-axis. So the limit as x approaches -infinity is equal to 0. So that narrows it down to either C or D. Now, how about the right end behavior? The limit as x approaches positive infinity. Well, on the right, this function is just decreasing it. So the limit as x approaches positive infinity is -infinity. So the answer is C. Let me just mention that the College Board likes to say that as x approaches positive infinity, g of x decreases without bound. That's why the limit equals -infinity. 24. The exponential function h decreases at an increasing rate. Which of the following could be an expression for h? I'm going to explain this problem to you in two different ways. Back in Unit 1, I tried to get you guys to memorize this chart showing the graphical relationships between f, the rate of change of f, and the rate of change of the rate of change. We are talking about a function that is decreasing at a decreasing rate. So the function itself is decreasing, so we're talking about this position, at a decreasing rate. In other words, the rate of change is decreasing. So that means we are here. It's the second one that I want you to kind of focus on at the moment, because this tells us the concavity of the graph. If the rate of change is decreasing, that's only going to happen when the function itself is concave down. So the decreasing rate part means that the function is concave down. You know what decreasing means. So decreasing means it's going to be going downhill from left to right, but the decreasing rate part means it's got to be concave down while it's doing it. So this is what a graph looks like when it is decreasing at a decreasing rate. Just for comparison, if they told us that a function was decreasing at an increasing rate of change means that the function is concave up. So we would know the function was concave up because of the increasing rate of change, but it's still decreasing. So we would know the curve would look like this, decreasing, but concave up. By the way, you will use this chart all the time in calculus next year. So you should pause the screen, write this in your notes, and study it. You should practice writing this chart down to the point that you should be able to take out a piece of scratch paper and write it from memory before your next test. One more time. Decreasing at a constant rate of change would be linear. Decreasing at an increasing rate of change would be concave up. And decreasing at a decreasing rate of change would be concave down. So if function h is an exponential function that decreases at an increasing rate, it must be decreasing but concave up like this. So now we can answer the question. It had to be above the x-axis for this, which means the a value had to be positive. That eliminates option A and option D. Also, from left to right, we had to draw it so that it was approaching 0. That means the b value has to be between 0 and 1. So that's why the final answer is C. Now I told you I was going to explain this two different ways. So if you were less comfortable with the whole chart that I was trying to get you to memorize, here's one more way to make you understand that decreasing at an increasing rate is going to be concave up like this. You know what decreasing means. Now, increasing rate. Let's put some estimations of slope along this graph. So, for example, somewhere in the middle here, let's say that the tangent line has a slope of -1. Okay, that would be like a 45-degree angle. As we go to the left, this is going to be steeper. Okay, so somewhere over here we have a steeper slope, so this is going to be like -2. Now somewhere down here this is not as steep. Alright, still negative, but the slope down here, maybe this is -1/2. So the question is, are these values increasing or decreasing? Well, if you put this on a number line, it would go like this. It would go -2, and then we'd get to -1, and then real close to that we would have -1/2, and then we would get to 0. From -2 to -1/2, we are moving to the right on this number line. These numbers are getting bigger. They're getting less negative. So that's why this sequence of numbers, this sequence of slopes is increasing. So that will only happen if you have a concave up graph. 25. The graph of the exponential function f is shown above. Which of the following pairs of statements correctly describes the end behavior of the graph? Well, this will be super easy. As we go to the left, f increases without bound. So I'm looking for one that says the limit as x approaches -infinity equals +infinity. So let's see, the limit as x approaches -infinity, -infinity, no. -infinity, +infinity, yes. And that's the only one that has that. So the answer has to be B. That's it. Let's look at the other side. As x approaches +infinity, notice that the graph is approaching the x-axis. It is approaching 0. So yes, the limit as x approaches +infinity is equal to 0. The answer is B. 26. The graph of the exponential function k is shown above. Which of the following could be an expression for k? we notice that the curve is below the x-axis. That means the a value, the number in the front, has to be negative. So that means B and C are out. We also notice that as we go from left to right, the curve is getting further away from 0. That tells us that the B value, the number that has the exponent, must be greater than 1. So between these two, we see that the answer will be A. 3. The B value is greater than 1, so the answer is A. 27. Let k of x equal negative 2 times 1/5 to the x power. Determine the end behavior of k as x decreases without bound. Express your answer using the mathematical notation of a limit. Begin by drawing a sketch. We see that the a value is negative. That means the curve is going to be below the x-axis. We see that the b value is between 0 and 1. That means as we go from left to right, the curve must be getting closer and closer to 0. So that's what the picture looks like. They want the end behavior as x decreases without bound. That's another way of saying as x approaches negative infinity. All right, x decreases without bound. Okay, so they want the left end behavior. So we will say the limit as x approaches negative infinity of k of x equals. All right, as x approaches negative infinity, k of x decreases without bound. It's falling, falling, falling. So the limit is negative infinity. 28. The exponential function f is defined by f of x equals a times b to the x power, where a and b are positive constants. The table gives values of f of x at selected values of x. Which of the following statements is true? The a value is the value at 0. So we can see this immediately because they give us the value at 0. A is 1/4. The b value is going to be the common ratio as long as the input values are changing by 1, which they are. So if I take each term and divide by the previous term, that's going to give me the b value. 2 divided by 1 is 2. Let's check one more. 4 divided by 2 is 2. The b value is 2. So that means putting it together, f of x is equal to 1/4 times 2 to the x power. Let's draw a sketch. Because the a value is greater than 0, we know the curve will be above the x-axis. Because the b value is greater than 1, the curve will be getting further away from 0 as we move from left to right. This is exponential growth. If we did have an example that was below the x-axis, this is neither growth nor decay. Exponential growth and exponential decay both have to be above the x-axis. That growth looks like that. Decay would look like that. So we have exponential growth. Okay, so that's either C or D. And it was because the a value is greater than 0. They both say that. And because the b value is greater than 1. Only D says that. 29. The exponential function g is defined by g of x equals a times b to the x power, where a and b are positive constants. The table gives values of g of x at selected values of x. Which of the following statements is true? Okay, this is just like the last one. All right, I can't actually tell exactly what the a value is without doing some work, but I don't really need to know the exact value of a. A is greater than 0. We know that because all of the values are positive. Okay, so that right there tells you that the curve is above the x-axis. So we know the a value is going to be greater than 0. Also, all of the answer choices say a is greater than 0. So we don't really have to worry about that. So let's focus on that b value. If this is exponential, and we're told that it is, the b value will be the common ratio. We can find that b value by dividing each term by the previous term, as long as the input values are 1 apart. And they are 1, 2, 3, 4, 5. So we can just divide each by the previous. So 10 divided by 1 is 10. So the b value is 10. So we don't really need to know what the function is, but we do know, we could draw a sketch. We already know the curve is above the x-axis because the a value is greater than 0. All of the values are positive. Since the b value is greater than 1, this is going to be exponential growth. So this is exactly the same as the last problem was. So the answer is D again, for the exact same reason. Number 30. The exponential function h is defined by h of x equals 3 times 1/2 to the x power. Which of the following statements about h is correct? And, well, let's draw a sketch. Because the a value is positive, we know the curve will be above the x-axis. Because the b value is between 0 and 1, we know the curve will be getting closer to 0 as we move from left to right. This curve is decreasing. We do see that it is falling from left to right, but is it decreasing at an increasing rate or decreasing at a decreasing rate? Because the curve is concave up, the rate of change is increasing. So our curve is decreasing at an increasing rate. Another way to think about it is by estimating slopes. It is steeper at the beginning and less steep at the end. For example, picture a slope of -2, and then a slope of -1, and then a slope of -1/2. These slopes are getting less negative. So therefore, the rate of change is increasing from left to right. Anyway, the answer is C. Function h is decreasing, and the rate of change is increasing. 31. Selected values of the function f are shown in the table to the right. Which of the following claim and explanation statements best fits these data? We know that f of x will be linear if the output values have a common difference over equal length input value intervals. And f of x will be exponential if output values are proportional over equal length input value intervals. We do have equal length input value intervals. Do we have a common difference? No. From 3 to 6, that's plus 3, and from 6 to 12, that is plus 6. So we do not have a common difference. F of x is not linear. To decide if the output values are proportional, divide each output value by the previous output value. 6 divided by 3 is 2, so that's the first ratio. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. So, exponential, yes. The answer is C. F is best modeled by an exponential function because the outputs over consecutive equal length input value intervals are proportional. The graph of the piecewise linear function f is shown above and consists of 3 linear segments. Values of the functions g and h are shown in the table above at selected values of x. Kabam! Let f inverse and h inverse represent the inverse of functions f and h. Number 32. Find the value of h inverse at 2, or indicate that it is not defined. Since we don't have a table or a graph for h inverse, we have to come at it indirectly. You should think to yourself, h at what is equal to 2? Let's see. H at -1 is 2. So that's the value of h inverse. Similarly, to evaluate f inverse at 2, ask yourself f at what is equal to 2. Here's the output value of 2. we can see that f at 0 is equal to 2. So that's the answer. 34. The function k is defined by k of x equals g of f of x. Here it is written with two different forms that mean the same thing. Find the value of k at 0 or indicate that it is not defined. We are still using this information up here. K at 0 will equal g at f at 0. We have to start with f at 0, and we see that f at 0 is 2. Then we move on to g. G at 2. G at 2 is negative 5. So k at 0 is negative 5. For number 35, we need to find the value of m at negative 3. But m of x is also defined by g of f of x. So m at negative 3 will be g of f at negative 3. Working from right to left, we must start with f at negative 3. So here's negative 3 input value, and we see that f at negative 3 is negative 1. Then we move on to function g. G at negative 1. G at negative 1 is negative 2. M at negative 3 is negative 2. For number 36, we must evaluate p at 1. But function p is equal to h at g. So p at 1 will equal h at g at 1. Working from the inside out, we begin with g at 1. G at 1 is negative 3. Moving to the outside, we get to function h. We must evaluate h at negative 3. H at negative 3 is 4. Therefore, p at 1 equals 4. For number 37, we must evaluate q at negative 4. But function q is f of x. So we must evaluate f of f at negative 4. Working from right to left, we start with f at negative 4. Let's see, here's negative 4, and here is f at negative 4. F at negative 4 is negative 2. Moving to the left, we get to another f. This time we do f at negative 2. Here's negative 2 right here. F at negative 2 is 1. So q at negative 4 is 1. 38. We must evaluate r at 1. But r is g of h of x. So we must evaluate g of h at 1. From the inside out, we start with h at 1. H at 1 is 0. Moving to the outside, we get to function g, and we must evaluate g at 0. There is no 0. So g at 0 is undefined. Therefore, r at 1 is also undefined. 39. We must evaluate L at 2. But L of x is f inverse at h of x. We must evaluate f inverse of h at 2. Working from right to left, we begin with h at 2. H at 2 is negative 2. Then we move on to the left, and we must evaluate f inverse at negative 2. We do not have f inverse. So we must come at it indirectly by asking ourselves f at what is equal to negative 2. The output value of negative 2 is down here. We can see that f at negative 4 is equal to negative 2. So f inverse at negative 2 is negative 4. Therefore, L at 2 equals negative 4. Number 40. Let f of x equals 4x minus 7. Find f inverse, the inverse of f. F of x is another name for y, and the first step for finding the inverse is to switch x and y. So I'm going to begin by writing x equals 4y minus 7. Then we just need to solve for y. Adding 7 to both sides, I get x plus 7 is equal to 4y. Dividing both sides by 4, I get x plus 7 over 4 is equal to y. Or I could have written it as 1/4 x plus 7 over 4 is equal to y. Since the original function was called f of x, not y, we need to use this notation and write f inverse is equal to x plus 7 over 4 with a -1 superscript. Number 41. Finding the inverse of a rational function takes a few more steps, but the first step is the same. I'm going to view g of x as a y, and I'm going to switch the x and y. So I'm going to write x equals 2y plus 7 over 3y minus 4. I need to get rid of the fraction aspect of this by multiplying both sides by the denominator. On the right-hand side, the denominator will cancel out with the 3y minus 4, bringing down the 2y plus 7. On the left side, I need to distribute this x. So I'm going to have 3xy minus 4x. My goal is to solve for y. It is a problem that we have y in two different places. To fix this, we need to get all of the y's on the left side of the equation and all of the non-y terms on the right-hand side. So I already like the fact that I have 3xy. Okay, so that's 1y on the left. I need to move the 2y over to the left as well by subtracting 2y from both sides. So now I have a minus 2y. I'm going to move the -4x to the other side of the equation by adding 4x to both sides. So this will become positive 4x plus 7. The reason why I put the two y terms together on the left-hand side is so that I can factor the y out because now it's a common factor. So we can bring the y outside of parentheses like this. That is going to leave behind 3x minus 2. To mentally double check this, imagine doing the distributive property right now. Would we not get 3xy and then minus 2y? So you know you did it correctly. On the right-hand side, we still have 4x plus 7. Now that y is out here by itself, I can isolate the y by dividing both sides by 3x minus 2. So that will leave y equals 4x plus 7 over 3x minus 2. All we need to do now is use proper notation. Because the original function was called g of x, we need to call the inverse function g inverse, like this. So here's the final answer. G inverse is equal to 4x plus 7 over 3x minus 2. We are basically doing the same thing again for number 42. So h of x is just like a y. Start by switching the x and the y. So I'm going to have x equals y minus 2 over 6y plus 4. Now I need to get rid of the denominator by multiplying both sides by 6y plus 4. On the left, I will distribute. So I'm going to get 6xy plus 4x equals. On the right, the 6y plus 4 and the other 6y plus 4 will cancel out, leaving y minus 2. Let's get both of the y terms on the left and the non-y terms on the right. So I have 6xy. Subtracting y from both sides, I will have a minus y here. Subtracting 4x from both sides, I will have negative 4x over here, and then the minus 2. Now we can factor out the y. So I will put y outside of the parentheses, and this will leave 6x minus 1 is equal to negative 4x minus 2. Now we can isolate the y by dividing both sides by 6x minus 1. So we can write y equals negative 4x minus 2 over 6x minus 1. Let's use proper notation because the original function was called h of x. The inverse will be called h inverse. When the leading coefficient of the numerator is negative, it is common to factor out that negative. So I'm going to show this in 2 steps so I can make sure you understand what I'm doing. If I bring this negative out, I'm factoring out a negative 1. So that would leave behind 4x plus 2. You know this is correct because if you imagine distributing a negative 1, it would get us back to negative 4x minus 2 again. However, this is not really how they like to write it. Now that I have factored this negative out, you won't mind if I put the negative in the very front of the fraction. This is how the answer would likely appear on a multiple choice question. 43. The decreasing function s gives the number of students inside a classroom after the school ends. The table gives values of s of t for selected values of t in minutes since the school bell ended the day. If a model is constructed to represent these data, which of the following best applies to this situation? Notice that the table shows equal length input value intervals. The first 2 options are linear functions. We will choose one of these if the output values turn out to have a common difference. The second 2 functions are exponential functions. These will be appropriate if there's a common ratio between the output values. If you divide each term by the previous term, you get 1/2. So there is a common ratio, and the common ratio is 1/2. So we knew the answer would be C or D because of the common ratio. Now, using the model, the general model f of x is equal to a times b to the x power, the b value is this common ratio. So we expected to see a 1/2 because of the common ratio. Also, the a value is the value at 0, which is 512. So we expect to see a 512 right here. So guess what? D. 44. After Mr. Passwater launches his new social media app called Passwater Vision, the number of users registered on the app begins to increase rapidly. The number of users in millions using the Passwater Vision app is modeled by the function p. The number of users is expected to increase by 21% each month. At time t equals 0 years, so be careful, these units don't match. There are 14 million users on Passwater Vision. If t is measured in years, which of the following is an expression for p of t? Note, there are 12 months in a year. Increasing by the same percentage each month is exponential growth. Here is the general model for an exponential function where the a value represents the initial amount, and there are 14 million users at time t equals 0 years. So let's put the 14 million right there. The b value is the common ratio. We can get that from the 21% in the following way. B is going to be 100% plus the 21%. 121% as a decimal is 1.21. So that is the b value. Now we have to be careful. I don't want to put a t right here because this percentage is in months. That means this exponent has the units of months. However, we want time to be measured in years. T has to be in years. So what do? We write a little conversion equation that converts months into years. So let's say I have the number of years. To turn this into months, am I going to divide by 12 or am I going to multiply by 12? Well, let's say we were talking about 3 years. If I wanted to turn this into months, I would do 3 times 12. That would be 36 months, right? 3 years is 36 months. So the number of months is the number of years times 12. However, the number of years is to be represented by the variable t. So 12t is 12 times the number of years. So the number of months is equal to 12t. Now we can replace the word months with the expression 12t without changing the value of the equation. So this is what we are looking for. Let's see, 1.21 to the power of 12t, and the answer is D. 45. A fitness trainer created a new fitness program designed to help her clients increase their bench press. The trainer made estimates about the maximum amount one of her clients could bench press over time using her program. A linear regression was used to develop a model for the maximum bench press over time. The figure shows a graph of the residuals of the linear regression. Which of the following statements about the linear regression is true? The main thing you need to know about a residual plot is that if it shows no pattern, that means the model used was appropriate. If you see any kind of a pattern, it means the model used was not appropriate. So we see no pattern here. That means that the linear model that was used is appropriate. So the answer is C. The linear model is appropriate because there is not a clear pattern in the graph of the residuals. Number 46. The distance in meters that a toy pullback car will travel after being pulled backwards c centimeters can be modeled by the function d, given by d of c is equal to 0.15 times 1.2 to the 2c power. Which of the following functions d models the distance the toy car travels after being pulled back m millimeters? There are 10 millimeters in a centimeter. They want us to rewrite this equation with m instead of c. So I need an expression that is equivalent to c, that involves m. They reminded us that m is equal to 10c. So we just need to get c by itself. Let's divide both sides by 10. So c is equal to m divided by 10. Now we can plug this expression in for c right here. So we will get d at m, right, because we're going to have m's now, is equal to 0.15 times 1.2 to the 2c. So this is going to be 2 times, and instead of c, I'm going to write m over 10. So basically this is 2m over 10. You can see that this is going to reduce. 2 goes into 10 5 times. However, m over 5, this is the same as 1/5 m. All right, I'm looking at the answer choices, and so I'm rewriting a little bit to make it more obvious. Remember that property where c to the a times b power can be rewritten as c to the a power all raised to the b power? We can use that to sort of separate the m. So that's what they're doing here. So that's why we have 1.2 to the 1/5 power, and then all that is raised to the m power. So the answer is D. 47. Polonium-209 has a half-life of 102 years. In a particular sample, the amount of polonium-209 remaining after y years can be modeled by the function p, given by p at y equals a0 times 0.5 to the y over 102 power, where a0 is the amount of polonium-209 in the sample at time y equals 0. Which of the following functions L models the amount of polonium-209 remaining after t days, where a0 is the amount of polonium-209 in the sample at time t equals 0? There are 365 days in a year, so t equals 365y. So, this function is written in terms of years, and they want us to rewrite it in terms of days, and t represents the number of days. So, if we want to replace y with something that has a t in it, we need to take this little expression, 365y is equal to t, and we need to get y by itself. So y is equal to t divided by 365. So now we should be able to take this and plug it in for y right here and simplify. This whole ugly expression is in the exponent. I had y over 102, but y is t over 365. So it becomes t over 365 all over 102. Dividing by 102 is the same as multiplying by 1 over 102. So I'm just going to put it off to the side so you can follow what I'm doing. So hopefully you can follow that this expression is equivalent to the one I had. In fact, this dividing by 365, I'm going to put that off to the side as well. In the exponent, I have three things that are all being multiplied. T times 1 over 365 times 1 over 102. I can group these in any way that I want. I could put these two together and have t over 365, or I could group these two together and have t over 102. It doesn't matter. We just need to look among the answer choices and find any of these. So I think the answer is going to turn out to be D. You see the t over 102, that's this option right here. And we have learned that we can regroup things with parentheses like this. When you have something raised to a product, you're allowed to rewrite it as a power raised to another power. So that's what they have going on right here. 0.5 to the 1 over 365 power, all raised to the t over 102 power. So answer D matches this. 48. The table above represents values for a function k at selected values of x. An exponential regression, y equals a times b to the x power, is used to model these data. What is the value of k at 3 predicted by the exponential function model? This little calculator means this is a calculator active problem. So let's use our calculator to find a regression model. Hit the Stat button and hit Enter. Let's put the input values in L1 and the output values in L2. Once your data is all in, hit the Stat button, switch over to the Calculate menu. Exponential regression is option 0. It's just below option 9. So you can either scroll down to it, or you could have just hit the number 0 if you memorized that. Before we calculate the regression model, I strongly recommend that you store your regression equation as y1. So you do that by hitting vars, switch over to yvars, hit enter, and then enter again. So now if we need the regression model, it will be waiting for us in the y equals area under y1. Hit enter a couple more times, and kabam, here's your regression model. We are being asked for the value of the regression model at 3. But in our calculator, the regression model is in y1. So we need to find y1 at 3. To make y1 show up on your calculator, hit vars, switch over to yvars, hit enter, and hit enter again. This will only work if you did tell the calculator to store the regression model as y1. So now, to evaluate this at 3, just put a 3 next to it in parentheses like this. And that's the answer, 1.654. So the answer is A. 49. As the population of a particular town begins to increase, the number of students enrolled at the local high school also begins to increase. The school district creates two function models, Q and E, to predict the number of students in thousands that will be enrolled at the local high school in T years. If Q of T is equal to 0.37 T squared minus 0.365 T plus 1.1, and E of T is equal to 1.216 times 1.31 to the T power, what is the time T that students' enrollment predicted by the quadratic model will be 0.05 thousand students more than the student enrollment predicted by the exponential model? Asking us when the quadratic model will be 0.05 more than the exponential model is another way of asking when will Q of T minus E of T be 0.05. I would love to type this into my calculator somehow, but it will be easier if the Q of T and the E of T are on opposite sides of the equation. So let's add the E of T to both sides of the equation, and this equation will become Q of T is equal to E of T plus the 0.05. To solve this equation, we can graph these in the graphing calculator and see where they intersect. So go ahead and type the left side of the equation in as y1. So type the quadratic equation in as y1. In fact, let's make a little note to ourselves that this side of the equation is going to be y1. And we're going to type this side of the equation in as y2. So type in the exponential function, but don't forget to add the 0.05 on the end of it as part of your y2. So your y1 should look like this, and your y2 should look like this. Don't forget to add the 0.05 onto the end of it. I don't know what the window needs to be. Let's go ahead and hit zoom 6 for a standard 10 by 10 window, and we can always make adjustments after that. So zoom 6, we're looking for the intersection of these two curves. Okay. It looks to me like this first intersection point is negative, which we will ignore because we can't have negative time. So I think we're just looking for this intersection point. So I could start doing my second trace intersect right now, but I just wanted to show you one more tool. Let me show you how to zoom in a little more carefully and easily, just so we can get a little bit of a better view. Try hitting zoom box. So hit zoom and then the number 1. Let's move the pointer to the lower left of all of this interesting stuff, okay, to the lower left of all of these intersection points, and hit enter. And then move your pointer to the upper right of where all the action is. You'll notice as you move your pointer around, it's showing you exactly what that window is going to be. So you can really turn this into just a perfect window to see what you need to see. Once you have the window exactly how you want it, hit enter. So now we can really clearly see that this first intersection point is in negative time, so we will ignore that. So we just need to find this. So second trace intersect is option 5. Let's move a little bit closer to the point of intersection and hit enter 3 times. Enter, enter, enter. 2.425. So the answer is D. Number 50. A wind turbine uses the power of wind to generate electricity. The blades of the turbine make a noise that can be heard at a distance from the turbine. At a distance of d equals 0 meters from the turbine, the noise level is 105 decibels. At a distance of d equals 10 meters from the turbine, the noise level is 49 decibels. The noise level can be modeled by the function S of d is equal to a times b to the d power, where S of d is the noise level in decibels at a distance d meters from the turbine. This problem is calculator active. Part A. Use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for S of d. At a distance of 0 meters, the noise level is 105 decibels. So if I plug in 0 for d, the answer should be 105. So the first equation is a times b to the 0 power is equal to 105. Similarly, at a distance of 100 meters from the turbine, the noise level is 49 decibels. So a times b to the 100 is equal to 49. These are the 2 equations that we can use to find the values of a and b. We can use our graphing calculator to find an exponential regression model, which will include the values of a and b. So we will enter the input values 0 and 100 in L1 and the output values in L2. However, before we do that, we already know what the value of a is going to be, because the a value is the value at 0, and the value at 0 is 105. So the calculator should confirm this, but we already know that the value of a is going to be 105. In fact, I think I'll show you 2 ways to solve this problem. The second way will be when I put this into the calculator, but I'm going to do most of this by hand right now. So, knowing that the a value is 105, we now can write so 105 times b to the d power. So we have 105 times b to the d power is equal to s at d. Alright, so we already have this. So let's plug the other point into this equation now. So if we plug in 100 for d, the result should be 49. So that gives us 105 b to the 100 power, and this should equal 49. So we somehow need to solve this for b. Let's start by dividing both sides by 105. So this will give me b to the 100 power is equal to 49 over 105. To get b by itself, I can raise both sides of this equation to the 1 over 100 power. I know this looks really weird. I just need to cancel out this 100. And when you raise a power to another power, you multiply. And if I multiply 100 times 1 over 100, these will cancel each other out. So if we type this into the calculator, it should give us the value of b. When you type it in, it should look like this, and kabam! 0.9 992. So that's how you would solve it mostly by hand. Now let's go back and try the other method. Let's type this into L1 and L2 and make a regression model. Let's see if we get the same answer. Hit stat and enter. Enter your input values and your output values. Then hit stat again, switch over to the calculate menu. And we want exponential regression, which is option 0. So either scroll down or you can just hit 0 if you remember that. Just in case we need it later. Let's store this regression model in Y1. Hit vars. YVars. Enter. Enter. Enter a couple more times to get the regression model. And kabam! A is equal to 105 and B is 0.992. Part C. Use the given data to find the average rate of change of the noise level in decibels per meter from D equals 0 meters to D equals 100 meters. Express your answer as a decimal approximation. Show the computations that lead to your answer. Remember the formula for the average rate of change on the interval from A to B? It's F at B minus F at A divided by B minus A. Our noise level model was called S of D. So the average rate of change of S of D on the interval from 0 to 100 is going to be S at 100 minus S at 0 divided by 100 minus 0. So we don't have an exact equation for S of D. What we have is the regression model that we just found in the calculator. So because we told the calculator to store the regression model as Y1, when you type this into your calculator in a moment, it's going to look like this. You don't need to write this on your paper. This is just so you know. It's going to be Y1 at 100 minus Y1 at 0 divided by 100 minus 0. This is what we're typing into the calculator. Set up a proper fraction however you know to do that. I can do alpha y equals enter. In the numerator we need y1 at 100. So I'm going to do vars, yvars, enter, enter. So that's y1. And now this is y1 at 100. Now I need minus y1 at 0. So vars, yvars, enter, enter. And that's y1 at 0 over 100 minus 0. And hit enter. Negative 0.56. Don't forget to include units in your answer. 51. Let f be a decreasing function defined for x greater than or equal to 0. The table gives values of f of x at selected values of x. The function g is given by g of x equals negative 4 times 2 to the x power. Part A1. The function h is defined by h of x equals g of f of x. Find the value of h at 0 or indicate that it is not defined. So it looks like finding h at 0 will be the same as finding g of f at 0. Working from the inside out, we first need to find f at 0. F at 0 is 8. Moving on to the outside, we now need to find g at 8. G is defined by this function right here. So g at 8, I'm just plugging in 8 for x. So this will be negative 4 times 2 to the 8th power. 2 to the 8th power is 256. So negative 4 times 256 gives negative 1024. So that's it for part A1. For part A2, we need to find the value of f inverse at 4. You can find f inverse at 4 by asking yourself f at what is equal to 4? F at 1 is equal to 4. So that's the answer. Part B. Determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. Let's make a little sketch of g to help us answer this question. We see that the a value is negative. That means that the exponential curve will be below the x-axis. We then see that the b value is bigger than 1. That means as we move from left to right, the curve will be getting farther away from the x-axis, farther away from 0. The end behavior as x increases without bound is the limit as x approaches positive infinity of g of x. As x approaches positive infinity, meaning as we go to the right, g of x decreases without bound. It is falling, falling, falling. That's why this limit is equal to negative infinity. Part C1. Use the table of values of f of x to determine if f is best modeled by a linear, quadratic, or exponential function. Because we have equal length input value intervals, we can focus on what's going on with the output values to figure out if it's going to be a linear model, a quadratic model, or an exponential model. If the first differences are constant, then a linear model will be most appropriate. If the second differences are constant, meaning the differences of the differences, then a quadratic model will be most appropriate. But if the output values are proportional, then it's all about an exponential model. That last one is what's sort of jumping out at me, so I'm just going to go straight to that. You can tell that the output values are proportional when each term divided by the previous term gives you the same ratio. For example, 4 divided by 8 is 1/2. So that is a ratio of 1/2. 2 divided by 4, also 1/2. 1 divided by 2, 1/2. And 1/2 divided by 1 is 1/2. So an exponential model will be most appropriate. And then for C2, we need to give a reason for our answer. I need you to use your College Board vocabulary, so your answer should be the same as mine, almost word for word. An exponential model is most appropriate because the output values are proportional over equal length input value intervals. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.